I'm Assistant Professor Aparna Kedari, and today we are going to study essentials of organic chemistry from Fundamentals of Chemistry 1. So let's start with inductive effect. The polarization. What is inductive effect? The polarization is induced in adjacent bond due to polarization is present in one bond. It's called inductive effect. Here you can see the inductive effect, that is polarization present in this carbon and chlorine, and here there is a polarization. Due to polarization in this bond, the polarization is induced in all other bonds, that is adjacent bond. Therefore, what is inductive effect? The polarization is induced in the adjacent bond due to polarization present in one bond. It's called inductive effect. A covalent bond between covalent bond between two different atoms, heteroatomic molecules such as hydrochloric acid, that is HCl, HBr, CH3Br, that is say methyl bromide. The bonding electron pair is not equally shared because the electronegativity of two atoms are not same. In this case, the chlorine is in HCl, the chlorine is more electronegative. Therefore, it pulled the bonding pair of electron towards itself and acquires negative charge. Hydrogen acquires positive charge. Same in the case of HBr, bromine is a more electronegative. Then in CH3Br, bromine is more electronegative than carbon. Therefore, there is separation of charges, that is plus and minus. There are some important features of inductive effect. The inductive effect is permanent polarization in ground state of the molecule, and it is developed due to the heteroatomic covalent bonds in molecule. Then it is associated with the sigma bond and connecting two dissimilar atoms or groups. The magnitude of the inductive effect is very small. It goes on decreasing with increasing distance from polar atoms or groups. Then types of inductive effect depending upon the direction of pulling of electron. The inductive effect are classified into two groups. First, electron donating inductive effect. It is denoted as a plus I effect. Second, electron withdrawing inductive effect, that is minus I. Then first, electron donating inductive effect. The atoms or group of atoms when increase the electron density around the atom, the effect is said to be a plus I effect. The groups which are negative, which have negative charge, have higher plus I effect than neutral atoms. For example, here O minus have higher plus I effect than OH. As electronegativity of atom decreases, plus I effect is also decreases because that is as electronegativity increases decreases, the A plus I effect increases. It increase more electron density around carbon atom. And next, generally as number of alkyl group increases, plus I effect also increases. Therefore, here this tertiary, there are total three alkyl groups which increase the electron density around carbon atom, positively charged carbon atom. Therefore, tertiary carbocations are more stable than secondary, primary, and methyl. As percentage of H character increases, the plus I effect decreases. For example, O minus, CO minus, CH3 thrice, CH3 twice, deuterium and hydrogen. The next effect is inductive effect is electron withdrawing inductive effect. Groups which have plus charge have more minus I effect than neutral atoms. Here you can see is this nitrogen is positively charged and this nitrogen is neutral. Therefore, positively charged neutrals the effect has more minus I effect than neutral nitrogen. As electronegativity of atom increases, the minus I effect increases. In fluorine, fluorine is more electronegative than iodine. Therefore, fluorine exerts strong minus I effect than iodine. As number of electronegative atoms or group increases, minus I effect increases. Then, as the percentage of S character increases, minus I effect is also increases. Here, plus I effect goes on increasing. Therefore, this is the order of uh, minus I effect. Then next is the resonance effect, mesomeric effect. It is also called mesomeric effect. The concept of resonance Many times molecule cannot be represented by one structure, or one particular structure does not explain all the observed properties of that molecule. Therefore, the resonance structure of benzene is proposed by KQ. Therefore, benzene is represented by this structure or this structure, and this is the hybrid form of benzene. These two equivalent structures have to be used to represent benzene. None of them is truly represent benzene. Therefore, the benzene should show two types of bond lengths, as carbon-carbon single bond should be closer to bond length of this carbon-carbon. There are two types of bonds in the benzene, that is carbon-carbon double bond and single bond. Carbon-carbon double single bond should be close to 1.14 angstrom radius and or bond length. Then carbon-carbon double bond should be close to 1.34 angstrom, and the X-ray crystallographic measurement indicates that benzene contain only one type of bond length, which is close to 1.34 angstrom, or that is all carbon-carbon bond lengths in benzene are equal. None of the above correct representation of benzene. Therefore, this proves that the pi electrons are no localized but totally delocalized. All 6 pi electrons are binding together 6 carbon atoms, making all carbon-carbon bonds equivalent. Definition of a resonance. Therefore, the phenomenon in which molecule is represented by number of interconvertible structures, but none of them is correct. The correct structure is represented by hybrid of all structures. The different structures of molecule are known as the resonance form or canonical form, and correct structure is known as the resonance hybrid. These are the examples of resonance. That is, in first is phenoxide ion O minus exert plus R effect, and benzene ring exert minus I effect. Therefore, this is the delocalization of electron. In second, that is in aniline, this nitrogen lone pair continuously delocalized on the benzene ring. Therefore, benzene ring exert minus R effect and NH2 group exert plus R effect. Then second case, here nitrogen is positively charged in nitro group. Therefore, benzene ring exert plus R effect and nitro group exert minus R effect. Therefore, this phenoxide ion are represented by these five structures, but it is exactly present in resonance hybrid. In case of aniline, again aniline is represented of this number of resonance structures, and this is the resonance hybrid of aniline. In this case, this nitrobenzene is represented by these five structures, but it exists as a resonance hybrid of nitrobenzene.